Now let's talk about expected value. What is expected value? Expected value is a measurement of the mean of a probability distribution. How do we compute expected value? If we assume that x is a discrete random variable with the discrete probability distribution p of x, then the expected value is defined by mu, which is the summation of x times p of x. Now let's see how we can find expected value using TI. First, we organize the problem in a table. Similar to this, one column for net gain and another column for the probability of net gain. We clear and reset all lists in the TI calculator. We enter the net gain in list 1 and probability of net gain in list 2. To emphasize, it has to be the corresponding probability. Then we perform basic computation using L1 and L2. I will show you in this video how to do it. An expected value is the value of x bar. For us, x bar represents mu, the mean, which is the measurement of the average for probability distribution. Let's look at a few examples. At a college fundraising event, the math club sold 400 tickets for $5 each. The winning ticket will receive a brand new calculator valued at $100. What's the expected value for net earning per ticket for the math club? There is only one winning ticket. So probability of winning is 1 over 400 because there were 400 tickets sold. And probability of not winning will be 399 over 400. Now, the amount of net gain for the winning ticket will be $100 for the value of the calculator minus $5 for the price of a ticket. So the net gain is $95. And the rest of the tickets each have a $5 net loss. We can make our table now. $95 net gain, probability of that 1 over 400. $5 loss, that would be negative 5, and the probability of that is 399 over 400. We're going to enter the net gain in L1, and we're going to put the probability of net gain in L2. And now we can find the expected value using basic computation. And for this problem, the expected value for the math club is $4.75 per ticket. I will use TI calculator at the end of this presentation for one of these examples to show you how you can find it. At the game, you can place a bet for $6 and draw a card randomly from a full deck of playing cards. In the event you draw a face card, the house will give you $26. Otherwise, you lose your $6 bet. What is the expected value of this game for the house per bet? So there are 12 face cards in a full deck of playing cards. Then probability of drawing a face card is 12 out of 52. And probability of not drawing a face card will be 40 out of 52. You can reduce these numbers, but once we use the TI will handle all those for us. The amount of net winning will be $26 from the house, but minus $6 to purchase or to pay to play. So the net winning gain would be $20 if you win. And if you don't win, you're going to have a net loss of $6. We make our table. So one column for net gain, another column for corresponding probability of net gain. Again, we're going to use L1 for net gain and L2 for probability of net gain. Once we do the basic computation, the expected value is 0. So this is considered a fair game. In other words, the house is not making any money. You win some, you lose some, so their expected value is 0. Let's look at this example now. An insurance company sells a 1-year term life insurance policy to Mrs. Young for a premium of $1,000. If she dies within 1 year, the company will pay $150,000 to her beneficiary. Assume the probability that she will be alive 1 year later is 99.5%. We want to find the expected value for the insurance company per policy. We're given probability that she will be alive is 99.5%, which is 0.995. And probability then that she will not be alive will be 0.005. If she is not alive, her beneficiary will receive $150,000 minus $1,000, of course. So the beneficiary will receive net gain of $149,000. And if she is still alive, she would lose her premium amount of $1,000. We're ready to make our table. We're going to enter the net gain in L1 and probability of net gain in L2. And we can use TI now to find the expected value, which is $250. And that net gain is the insurance company is making $250 per policy of this kind. Now I will show the last example on a TI how to do it, and I'm hoping that this presentation will help you understand how to do expected values. Okay, let's use TI calculator and compute the expected value for the last example that we had in the lecture over expected value. First, I'm going to clear all lists. To do that, I press second, followed by a plus key, option 4, enter. Now I'm going to also reset all lists. To do that, I'm going to press stat. Under the edit option, I'm going to choose option 5. And to execute, I'm going to press enter. Now we have to enter the net gains in L1 and probability of net gains in L2. So for that, I'm going to go to Stat. I'm going to go to Option 1. My L1 will be 149,000. And the second one is negative 1,000. The negative is the one next to the enter button, and then followed by 1,000. Now I'm going to go to L2 and enter the corresponding probabilities. The corresponding probability for the first one is 0.005, and the corresponding probability for the second one is 0.995. So we did enter the net gains and the probability of net gains in L1 and L2. Now I'm ready to do my basic computations. I go to Stat. I go to the Calculation menu. I choose Option 1. My list will be L1, and my frequency list will be L2, and then I go to Calculate. Now, if you do not have menu, you just have to use L1, L2 followed by enter. So in this calculator, I have a menu, so list L1, frequency list L2, followed by calculation. Again, if you do not have a menu option in your calculator, you just need to use L1, which is directly above number 7, and then L2 followed by enter button. And to get to L1 and L2, you basically use second 1 for L1 and second 2 for L2. So I'm ready to calculate now. So as you see, X bar, which is our expected value, is negative 250. In that example, the negative 250 simply indicates that the insurance company is making $250 per policy. Well, once again, I hope this presentation helped you understand how to find expected values when you are working with discrete probability distribution.